Okay, oh, I left this up here. Oops. Oh no. Sorry. Well, I guess I'll just have to leave that up. Um, I was reminding here that this f of x stands for the function named f, which takes x as input and gives you out whatever this does. So remember that this was the function name f, and what it does is whatever operation this is, and it gives you out, after you put something in, it gives you out whatever this does to it. Well, the reason why I'm talking about that is because this right here is called the inverse. It's called the inverse of f. And what it does is here we input something. We input something and we get some output, right? Now here in this one, what's interesting is the output that we get here. If we put that in, we get our input back out. So it's weird. It's like the reverse of what this is, and that's kind of the reason why it's called inverse. So that's just to let you know sort of what it is. And so let's start now trying to just figure out how to do this. It's actually very easy. I'm going to rewrite it now as this. It's a lot easier just to rewrite it as this. So this was our original thing. And I replaced f of x with y. Okay, so I got rid of this, and I put a y in there, and it's just easier, and I'll show you why it is. So what we're going to do to this is the way to find the inverse is it's really simple. Once you do this part of replacing it, it's really simple. All I'm going to do is I'm actually going to switch my x and my y. I'm going to flip them. So x goes out here, and the y goes in here. Okay, so I've flipped these now, and now my x is right here, and my y is on the inside. And now my task to find the inverse, all I have to do now is get y alone. So once I've flipped them, I just want to get y alone again. Okay, and so we're going to do this just by what we usually do, which is just balancing equations. And so I'm going to add 5 here to both sides. Okay, and that's my first step. And I'm going to get x plus 5 equals 1/2 y. And then my final step is actually just going to be, and again, this is not a bad problem, it's going to be to multiply both sides by 2. Okay, and you'll notice that, again, well, why don't I break it down? I'll distribute this, and I'm going to get 2x plus 10. Dang it. 2x plus 10 equals, and it's going to be 2 over 2y, and so that's just going to end up being 2x plus 10 equals y. And now at this point what I do is I just bring the inverse notation back in. So I've got this now, and I changed it to a y because it was a lot easier to do. But now what we actually have is we actually have the inverse. It's a good way to get our inverse. So this right here, what I've got is the operation that basically is what our inverse is going to be. So if our original function was f of x, and our original function was f of x, I'm just forgetting what it was exactly. F of x equals 1/2 x minus 5. So our original function was this, then our inverse is going to be 2x plus 10. Okay, and you notice we could put, I don't want to belabor this too much, but we could put any number in here, and you would see. Like, let's just put in something easy. Let's put in 2 here. Well, when we put in 2, we get 2. This becomes 2. 2 divided by 2 is 1. 1 minus 5 is negative 4. So when we put in 2, we get out negative 4. I know I'm doing that kind of fast, but the reason why I'm doing it fast is just to show you that when I put in negative 4 to this one, well, 2 times negative 4 is negative 8, and then negative 8 plus 10 is 2. And so what's crazy about this is there's the 2 and the 2. The 2 comes out here, so that's our output here, yet it's our input here. And so that means that what we've got works. What we've got is actually the inverse. So I think this was it. Yeah. Okay. All right. So here's the next one. This is the one that I'm going to try to do the graphing on. But so to start, this looks a little bit harder, but it's the same sort of concept, right? I have this function named f, and I want the inverse of that function, and so that's what I'm going to try to get here. So what I'm going to do is I'm going to change it into y equals 6 x to the 4th. So I'm just replacing it, and again, there's really no reason behind it other than just me making it easier on myself. And then x equals 6y to the 4th. So what I do at this point is I just start solving again, trying to get y alone. Again, it's get y alone. That's my next step. Okay, so first thing I'm going to do is divide by 6, right, because we're going reverse order of operations. And I'm going to get x over 6 equals y to the 4th. And then finally, there's only really one more step, and what they do here, I'm pretty sure, is they raise both of these to the 1/4 power. And now that might be kind of confusing. They raise both of them to the 1/4 power. That might be kind of confusing. Let me just do it first. I'll do it out first. We get x to the 6 to the 1/4 equals y to the 4/4, or 1. So it's looking right now that this is my inverse, right? Because this is now y to the 1, or y. And so this looks like this is my inverse. I've gotten y alone again. So it looks like this. If you were confused by the 1/4 thing, which I can't remember whether we really did that or not, just remember that when we have an exponent like this, the top here, that's our power, and this is our root. And so it would make sense that if we were trying to get rid of this, which is the power of 4, this is the power of 4, then we would get rid of it by doing the opposite, which is the root of 4. And that's what this is. That's what 1/4 as an exponent is, if you had forgotten that. So this right here is the same exact thing as the 4th root of x over 6. It's supposed to be a square root sign, but okay, so it's the same thing as that. But this is our inverse. Now, I wanted to put a video in here with this, showing you how to graph it on the calculator that you have. And if it's in here, if it gets in here, then what you would see is you would see me quickly graphing this inverse, right? And what you would see is you'd see that it's not gonna work. And the reason why it's not gonna work is because when we take a square root of something or a 4th root of something, it actually has 2 parts. So it's always a plus or a minus. Remember, that was the thing where I said, well, we know that 2 squared equals 4, and negative 2 squared equals 4, right? So if we just take the square root of 4, well, we know it's something with a 2 in it, but it could be plus 2 or it could be negative 2. It could be either one. We don't know. And so what you'll see here, and I might have just written over it if I actually put it in, is you'll see that when I'm graphing this, it's not a function. because it looks like this. And if it looks like that, right, and I'm just thinking now, I might not even put this in or even try to. If it looks like this, right, and I have an x value, that x value is now unreliable. It's just like that vending machine. It can give us out a Coke or it can give us out seltzer water. We don't know what we're going to get, and that's why that's the case. Okay, this is getting really long, so I'm going to try to wrap it up. I'm going to tell you with this one now. I'm not even going to read it, okay? I'm telling you what they're asking you here has got to be, it's got to be just the inverse. So, well, maybe I'll go through real quick. If you deposit 1,000, then the balance in 3 years is given by this, where R is written as decimal. What is the formula for the interest rate required to achieve? Yeah, so this is just the inverse. So if we think of B of C as the original function, then what I want to find is really just, I just want to sort of unravel it, okay? And it's not strictly an inverse, but first thing I'm going to do is, let me just do it real quick, just so you have the answer to this one, you're good to go. It looks like I'm just going to, I'm wondering, you know what, let me skip this one and come back. Okay, let me go to the last one I was going to do. So this one right here, the inverse of this is also function. I just talked about this, right? If we take the square root of x squared, we're going to get plus or minus x. We don't know which one it's going to be, okay? And if I do that video thing, then it's going to be here just showing you that, again, we're going to get something that looks like that. It's not going to be a function. Let me go back up to this. Sorry about this real quick. So I'm guessing what this is going to cut off everything too. Alright, well, I'm guessing what this is saying. Let me actually read it. The balance in the account up to 3 years is given by this, where R is written as a decimal. What is the formula for the interest rate R required to achieve a balance of B in the account? Yeah, it looks to me like they're just unraveling this, and I think we're actually doing it right. So I'm going to just continue doing it. I thought it was an inverse problem, but it doesn't seem to be an inverse problem. So I'm just going to call this B because that's what they look to be doing in the answer there. So it's going to be B over 1,000 equals 1 plus R cubed. And then again, I'm going to take the 1/3 of this and the 1/3 of that, and then I'm going to get, let me move down a little bit, I'm going to then get I'm going to get B to the 1,000 over 1/3 equals 1 plus R. Okay, I'm going to minus 1, minus 1, and then I'm going to get down here B over 1,000 to the 1/3 minus 1 equals R. And then finally, I'm going to rewrite it in the way that I think that they wanted you to write it in. And that way is with, remember, this is right there, that's your root, and this is your power. So that's going to mean that this right here, B over 1,000, is going to be cube rooted. Okay, I'm writing it in the same way that they want you to write it. And so that's going to be my final equation. Sorry if you can't really see that. I don't know why it shows green. So it looks like, well, they changed it to a negative 1 if you look. But so ours was minus 1, the cube root of B over 1,000. So it's looking like, and what else they did too is the cube root of 1,000 is 10. So they did that too. I didn't see that. So now we just have cube root of B over 10 minus 1. They actually applied this. The cube root, 10 times 10 is 100. I didn't see this. Times 10 is 1,000. So they actually applied this. So let's go back up and see it again. Looks like the answer actually is -1. They all look pretty similar to me. 10. I'm guessing it's gonna be this one, which I screwed up by cutting it. So it looks like it's that one. So at least you have a few answers here. And sorry this one was so long. I screwed up. Anyways, I will hopefully get those videos